But yeah, welcome everyone to our first Curious workshop. Today we're going to be learning about how to build a smart calculator. Oh, it's pretty distracting people joining in. But yeah, we're gonna learn how to build a smart calculator in Python. If you guys haven't already, please go into the workshop chat channel. I wrote something about what's your experience with Python. So if you haven't already, please check whether you're A, B, C, or D, depending on your experience, because I want to make sure the workshop is tailored for you. So right now I can see 5 people who have no experience with Python and 4 people who have very basic experience with Python. So based on that, I'm going to kind of tailor the workshop around you guys' experience. Awesome. So there's 6 now with no experience. Okay, that gives me a good idea of what kind of skill level I'm looking at. So today what I want to do is, let me just start this presentation, is first give you guys an introduction to what Curious is, because we're still a relatively new nonprofit organization, and it'll be like 5 minutes introducing you to what we're doing, and then we're going to go into the content, which is going to be a large part of the workshop, and I'm going to conclude, and we're going to share with you some resources so that you can continue learning about Python. Alright, so first of all, what are we? Curious. As you can see, we are a nonprofit organization, and we were created actually during last summer, but we haven't, I guess, we had a few roadblocks, but our goal when we came together was really provide tools for the youth so that you guys can change the world with technology. I know it sounds kind of bold, but really, essentially, we're trying to make coding as accessible as possible to the largest population of students in Montreal and Quebec, and we want to connect people who are like-minded. And our mission, in a quote, we can summarize like this: young people, when informed and empowered, when they realize that they can truly make a difference, can indeed change the world. So what you guys can see us as is a platform for you guys to continue learning together, to have sort of community, support each other. And actually, on our website, which is curious.ca, we have a list of resources. I can show it to you guys right now. So let me go on Google F11. So we prepared a list of resources actually. Right now, we just made it about 2 weeks ago, but we have a list of resources for you guys to get started if you want to start coding. And these are all courses that we linked, and we're also actually gonna start a blog soon. We wrote 1 article so far, but there's more to come. And let me go back to my presentation. These are going to be resources. The blog is going to be student written, and they're going to relate to various things about coding and opportunities. So yeah, and resources, as I talked about before, we put together for you guys to get started coding, but there's also more advanced things. So there's web development, there's machine learning, there's game development, app development, etc. And that's essentially what Curious is. Before we wanted to organize like physical events, but because of the coronavirus, now we're shifting to online events, and we thought maybe Discord would be a nice idea. So if you guys have any friends who want to get started in coding, or you have like a project idea in mind about coding, this is the perfect place, because you guys can actually, we have some mentors. We're trying to get as many mentors as possible to support you guys. If you guys ever have, some projects that you want to work on, but you don't really have coding questions, and you can ask them, and we're going to try our best to help you out. For those that I'm hearing like some people talking, but some background noise, so please mute your mic if you just arrived. Thank you. So with that in mind, let's get started. This is the exciting part. We're going to build a smart calculator. And what I mean by smart is we wanted to have a bunch of functionalities. So let's first go over our materials. So what you need are very essential: your computer, your Wi-Fi. And I wrote calculator because if you want to validate some of the things that we are going to do, then a calculator is also very useful, but it's definitely not mandatory. All right, so let's get a brief overview of what you're going to build today. You're going to first, before actually part one, building a quadratic solver, because I see that most of you guys are beginners, we're going to introduce some basic coding concepts. And then with that knowledge, we're going to be building a quadratic solver. In our second part, we're going to plot functions. So you can think of this as like the Desmos for code. So we're going to build a Desmos with Python. And then it's going to be pretty simple. In part 3, I'll be showing off like some cooler plotting functions. Like I'll show you guys how to plot an ellipse. But it's going to be rather advanced. So we're not going to code it entirely, but I'll still show it to you guys because it looks really cool. And then we're going to be differentiating and integrating using Senpai, which is a Python library. So we're not going to like, it's going to be partly coded because we're going to use code that I guess other people have already written and incorporate it into our code. So it's much simpler. And then in part 5, I'm going to show you guys something called latex, which will beautify the output. So if you guys are beginners, like some of the things I said might sound like unfamiliar. That's okay. We're going to explain these concepts now. So the first thing is I have to explain is how code actually gets executed. So how code gets executed. So the way it works is these languages like Python, like JavaScript, are languages that humans can understand. So this is what we call the source code. With that code that you have written, you have to pass it to a compiler. And what the compiler does is it transforms that human readable code into something that a machine can understand, which is binary. So it's filled with zeros and ones. And finally, the machines are going to read your code with the transform code that it can understand, and it's gonna execute it, and it's gonna return what you want. So for example, if your source code was like to print something in the console, like just print out some text, it's gonna take that code that you wrote, it's gonna compile it, it's gonna transform it into binary, and once it understood your code, it's gonna return the thing that you wanted, which is this output. And the thing is, that sounds pretty complicated, right? So we have things called IDEs, or integrated development environments. And these really simplify your life because all you need to do is write your source code, and this IDE will take care of the rest. So it's going to compile it and then transform it, and then you're going to get from this point all the way, like you're going to directly get your output. So today we're actually going to use an IDE to code. I wrote REPL.it and PyCharm because these are the two main. Use PyCharm, but for today, to keep it simple, we're going to use REPL.it. And REPL.it, it's a website, so I'll ask you guys to go on it right now. And it's an online IDE, so you guys can write your code online, and you can execute it online, so you don't need to do anything with your computer. It's just a website. The thing is, today, there's some things that are only going to work if you do it locally on your computer. And for that, I suggest using PyCharm. But if you're just a complete beginner, I wouldn't suggest you getting it, maybe towards the end of the workshop. But for people who are like more intermediate, who already have like some good knowledge with Python, then you can try out PyCharm and executing some things. I'll show you what you can do in PyCharm that you can't do in REPL.it. But yeah, for the sake of today, we're going to start coding REPL.it, and I'll showcase some things that I did with PyCharm. Alright, so let's get started coding. So I'm going to open up my browser, full screen this. So you guys should land on this page, right? REPL.it, and we're going to start coding. So I'm not going to sign up, I'm just going to directly start coding. And the language, as I said, we're going to use Python. So this is a language that humans can understand. And the difference between like different coding languages is mostly grammatical, like syntax. Just like how there's a difference between French, English, and German. Different coding languages, in essence, just have like different grammar. There's more to that, but that's essentially, for a beginner, what you have to know is it's more like syntactic and grammatical differences. So once you get to know like a coding language very well, it's very simple to switch over to another language because you understand the theory and why code works that way. All right, so let's get started. We want to build a quadratic solver. What that means is, I'm sure, I assume most of you guys are in either CJEP or like end of high school. So when we want to solve an equation, right? So I'm just going to start writing here. Like, this is not code that's going to be executed, that can be executed, but I want to show you guys. So 5x, let's say 5x squared plus 2x minus 5 equals 0. So this would be an equation you want to solve for x. So what you would do is take minus b, so minus 2 plus or minus square root of b squared minus 4ac over 2a, right? Everyone knows that. So how do we do that with code? Well, first of all, we have to understand how do we write out equations in Python. So over here we have an interactive shell. This is very useful because you can just write and it returns you something. So things like print hello world can directly return to you hello world. So the way it works, so for example, if you want to do addition, you can write out numbers and you can add them together, and this gives you an answer, which is 10. You can do multiplication by using an asterisk, or let me do something simpler. An asterisk. So 10 times 6 is 60. For the spacing, it doesn't really matter if there's a space between the letters or if there's no spacing between the letters. So if like this and this, it's the same thing. But I would rather you write something like this because it's easier to read. So you can add, you can subtract, you can divide using the slash, and you can actually do powers. So 5 to the power of 5, no, 5 to the power of 3, which is 125. You can do that. And you can even do square root, right? So square root is basically to the power of 1/2. So you can do 5 to the power, oh no, this is something, 25 to the power of 0.5, which is, 25 to the power of 0.5. There we go. Okay, so we've learned about arithmetic. Now we have to understand what are functions. So functions, the way I like to think of it, I'll refer back to my presentation over here. Functions are blocks of code which are only run when it's called. So in math we have functions, right? You take some sort of input and it returns to you a transformed like output, right? So if you have f(x) equals 2x, the input would be x and it returns to you 2x. It's kind of the same thing in Python. And what's cool, or any coding language, what's cool with functions is that you can reuse them. So the way I like to think of it for functions is just like how you would teach a robot how to cook. So let's say you want to teach the robot how to cook an egg. What do you have to tell it? You have to tell it to first take the egg, crack the egg, mix the egg, put some oil onto the frying pan, heat the stove, and then put your egg. There's a lot of things, right? And every time you want it to cook an egg, you're going to have to tell it all of these things. But if you can just build a function and tell it to cook an egg, and you write everything that it needs to do, and you can just call the function in the future instead of writing everything, that greatly simplifies your life. So functions simplify many things, and they reduce the clutter in our code because they are reusable. So that's what we're going to do for our quadratic equation. We're going to build a function that's going to take the 3 parameters, a, b, c, and it's going to return to us the answers, right? So a quadratic equation either has 0, 1, or 2 answers, and it's going to return to us those values depending on how many answers there are. So let's get started. The first thing we need to do is define our function. So the way we start with a function is writing def. And we're going to name our function. So you can name it anything you want, but I'm going to name it solve or quadratic solver. And don't worry about the underscore. It's just a standard procedure. There's like syntax attached to, there's syntax, like standard methodology that you should follow whenever you write things. Just like how when you're going to define variables, which I'm going to introduce shortly, it should start with something that's not capitalized. So this is our function. Our function's name is quadratic solver. And the parentheses, you can leave them empty. But in this case, we want to specify the 3 parameters, right? The 3 arguments. So the arguments are A, B, and C. The function will take these arguments and it's going to return them something, right? So what do we want to do with these arguments? Well, let's write out our equation. So it's minus b plus or minus. Okay, so we already have a first problem. There might be 2 answers. So we're going to store these answers. Let's start with plus, actually. So minus b plus square root of something, right? So just like in how in real life we have how the parentheses work in math, you can do the same thing in Python. So we want to take everything inside of the square root, or everything inside the parentheses, and put that as a square root. And inside the parentheses, it's b squared, so b to the power 2 minus 4 ac. So 4 times a times c. Right?
What the fuck? Hold on.
Divided by 2a. So that's your first answer. And we have to store this answer, right, somewhere, because we're going to need it later on. And these are what variables are useful. Why variables are useful. So the way we define a variable is we write the name of a variable. We can call it anything we want. So I'll just call it answer1. And then I use an equal sign to assign the thing to the right to the thing to the left. So let's take a look here. Oh. Can we clear here? No, okay. Anyways, so let's say I want to assign something, a variable. So a is equal to 5. So I want you guys to try it out in your own interactive shell. So try to assign some values. So a equals 5, b equals 2. And instead of writing like 2 plus 5, you can write a plus b. And it's the same thing because the Python, the computer knows already, because you told it that a is equals to 5. When you say a, it's going to look at a and it's going to be like, oh, this is 5 and b is 2. So 5 plus 2 is 7. And that's how that works. So our first answer is that. The second answer is going to be the same thing, but instead of a plus sign, it's a minus sign. And oh, this here I should also put parentheses. And we don't want to use the same variable, right? So let's use a different variable. So answer 2. Okay, so now we have these 2 answers, and it could work. If let's say we run this, right? So let's print our answer 1, answer 2. So let's call this function on something we know, quadratic solver. What could have an answer? 5, 4, minus 5. So let's try running this, and what it should do is print out answer 1 and answer 2. Alright, so let's run this. So you press run, and there we go. We have our 2 answers, right? So it works. But the thing is, what if it's like this? So if c is equal, or actually, let's say it's just x squared, right? So this would be a 1. X squared has 1 answer, which is 0. Oops, F11. So it's 0. Oops. Let me try running this again. So it's 0 and 0. They're both the same answers, yet it returns you 2 things, but they're both the same answers. But there's only 1 answer, right? So to avoid that, we can use an if statement. So we can compare answer 1 and 2, and if they're the same, just print out one of them. So we can do that by doing a comparison. and we use the double equal sign. Watch out for the double equal sign. It's not an equal sign. So the double equal sign doesn't, the equal sign assigns a value from the right to the left. The double equal sign compares the values. So we want to compare answer 1 and answer 2. And if this is true, then it does something, right? So if it's the same, we just want to give it print answer 1. And if else, so if this is not true, then you would do that. All right. And now if we try this, instead of 0, 0, it should just give us 0. So one answer instead of 2 answers. There you go. All right, so we only have 1 answer. Now what if we had no solutions? So something like 1, 0, 1. So x squared plus 1. There would be no answer, because here, well, here it will be negative, right? Because b is 0 and c is positive. Minus 4ac is going to be negative, and you're going to take the square root of a negative. So let's just see what this gives us. It's going to give us this, which doesn't make sense. It's like imaginary numbers. So how do we fix that? We're going to do something called try except. And the way we, first of all, we have to convert this. It doesn't give us it doesn't give us an error yet, because this we need to specify that it's a float. So that's going to convert to what we know, like a float is basically a number with a lot of decimals. So you have integers, which are like 1, 2, 3, 4, 5, 6, and then you have floats, which are 2 point. Like this would be a float. Okay. So let's first convert this to a float, and then we should get the error we expect. So now we got an error, right? Because we can't convert the imaginary numbers to a float. So how do we avoid that? Well, we have to pass this into a try except. So what that does is it tries to catch the error. So within this, if it fails to convert that to a float, then we're gonna have to say, so we do except, let me just first write this, except print no answer. The two quotes here means that it's a string. Okay, so strings are another type of data. So far I talked to you guys about float, integer, and strings. Okay, so integers, to remind you, are the things without decimals. So 2, 3, 4, 100. Floats are things like 1.35, right? And strings are things within a quote. Okay, so this will be a string. What happens if you don't put strings around it? So if you just wanted to print out no answer, this is going to give you an error, because it considers these two as variables, but they haven't been defined before. So it's going to give you an error. That's why you want to put it inside a string. Does that make sense? And Fred, let me know if I'm going too fast on some things. And yeah, if you guys, there's some things you're not clear about.
You may be going a bit fast on a bit of the basic stuff, like what's a variable, explaining the different types of data, all that. And if else, all of that. Like I want just to explain like what they do and all that and how they work.
Okay. If you guys, there's some things you guys are not clear about, please write it in the workshop channel, and I'll make sure to answer it, because I don't have an idea of, I think I'm explaining well, but if there's some things that I'm going way too fast over, please let me know. Let me or Fred know in the workshop channel, text channel, please. But let's recap the logic. So we're going to try and, first of all, if if it gives us an error, we're going to catch it and say there's no answer, right? Because this is going to give an error. If this is not going to give us an error, then there's two possibilities. One solution or two solutions. If there's one solution, i.e. the first answer and the second answer are the same, then we just want it to return one answer, right? So, and it doesn't matter if it's answer 1 or answer 2, it's the same thing. Indentation error. Okay. Yeah, I should talk about indentation. Basically, the way Python works is with indentation. So whenever you define a function, let's say you define hello, which is a function, and you write print hello, the problem is that it doesn't know what the way Python differentiates what's inside a function and what's outside a function is through indentations, and it's the same thing with if-else statements. When you indent this means that indent is just like you pressing tab. Okay, so you have your tab which is above the caps key. When you indent this means that it's going to be inside the hello function. So whenever you execute hello, it's going to execute this line. But if you don't indent this and you execute hello, it's going to give you an error because there's nothing inside your function, and you can't do that in Python. All right, and the reason why it's in red is because the hello function is empty.
Yeah, Gong.
Yeah.
Another thing that might be happening here is that if you forget the cones, it won't indent by itself. The cones at the end of the line are important because it tells you that everything after this will be part of this function. So you really need to put the cone at the end.
This colon, right?
Of the line. Yeah.
Yeah, exactly. And the same thing.
If you put the cone, it indents automatically.
Okay, yeah.
So if there's an indentation error, it's very probable that the person just forgot.
Even REPL.it, they know, like, see, whenever you indent well, you can like close this. So everything inside your function is this thing, and when you close it up, it's like that. Let's say if you forgot to indent your print and you close this, well, your print is now outside of your function. So make sure that you indent your stuff well, okay? So now this is good. So recap, 2 answers, you print both answers. If there's one answer, because both answers are the same, you only print out one of them. And if there's no answer, i.e. this returns an error because it can't take the square root of a negative number, then it prints out no answer. And then you can just solve it. And let's try something else, more complicated now. So let's try like -4, 5, and 1. Right? So let's run this. And there we go. We have our 2 answers. So something that could be useful I want to quickly introduce is a while loop, right? So if you want to do let's say you want to do your homework and you got to solve quadratic equations and you want to confirm everything, to run this code you would have to modify this every time, right? So a quick fix so that you don't have to rerun this every time would be to do a while loop. And then loop, basically what it's going to do is like, let's say these are code, until it's going to keep running everything inside until something tells it to stop. Okay, we can quickly write a while loop here. So let's say a is equal to 5. All right, and while a is smaller than 10, it does something. All right, so let's say print it works. And okay, I guess you can't do while loops in this interactive shell, but what an example of a while loop would be while a is, let's say a is equal to, I'm not going to run this, but let's say a is equal to 5, while a is superior than 10, you print it works, and then you're gonna add one more value to a, right? So the plus equal just means it's the same thing as a equals a plus 1, right? So I'm just gonna write plus equals, it's shorter. So It runs this once. So the first time it runs, a is equal to 5. And then at the end, a is equal to 6. And then it goes back here, and it checks if this is true, right? And if this is true, then so a now is going to be 6, but under 10. So the first time it's 5, since 5 is under 10, it's gonna run this once. And then a is equal to 6. It's still true. It runs until a is gonna reach 10. And when a reaches 10, this is no longer true. So everything inside the loop is not gonna run anymore. And then you move down, right? So the code runs from top to bottom. Okay. And you can do while true, which is always gonna be true, right? Because true is true. While true. Okay, so what was I saying? It's gonna run this. As the only way to break out of this is if you write something like break. Okay, break is gonna basically break out of the loop, but we don't want to break out of the loop, right? We want to keep the code running as long as possible, and what we're gonna do is, right? We can let the users input. And the way you write that is you take an input, and you can specify a. Hey, let me just write this out first, and then I'll explain. A. So A, B, and C. Alright, so while this is true, it's gonna take 3 inputs, A, B, and C. So once you run this, you're gonna be able to type in something. You'll see, and then with these inputs, you're gonna compute your solution, right? So quadratic solver, sorry, and you're gonna pass in your 3 inputs, right? So the A here is referring to the A here, right? The B here is referring to the B here, and make sure to not. Would it be possible to record the screen so we may refer back to them later? Yes, I'm actually recording this right now, and we're gonna put it on our website so you can refer back to it later. And I'll also the PowerPoint presentation, I'll also put it up. Yeah, no problem. So the quadratic solver, what I wanted to say is make sure to not confuse the ABC here to the ABC here. These are arguments. They're not actually like defined variables. Like we haven't defined them. So within the function, yeah, this might be a little complicated, but inside the function, the B here refers to the B here. It doesn't refer to anything outside of the function. And when these 3 actually refer to what's going to be inputted, right? So when you run this function, the A here is going to be equal to -4. The B here is going to be equal to 5, and the C here is going to be equal to our 1, right? And that's kind of how you automate your function, because remember when I was talking about like robots and it doesn't really apply because the robot example was about automating the same process. But let's say you had a robot with a bunch of recipes, right? And you have this large function, and you can specify what you want. So you have egg, you have rice, and if you can input, there's like so many inputs you can put as arguments, and imagine this as just like food, right? And you can specify the food, and then inside the function is going to recognize the food and do something appropriately, right? So here, this works, like we can write any number and the quadratic solver still works because it's gonna the function is gonna refer to the numbers that are passed. Damn, I'm kind of explaining this badly. Fred, do you want to jump in and help me while I drink some water because my throat is really dying?
No problem. So basically, can you just scroll back up? Yeah. Just to the function. Yeah. So basically, when you define a function with the def command, you give the function a name, and then when you put the parentheses, you give the function a bunch of arguments. You can put as many as you want. So basically, in this function, you have the argument A, the argument B, and the argument C. What this means is that when you call the function later, which is what he does here on line 22, you have to specify between parentheses the 3 arguments that you're going to use to run this function. So basically inside of this function, what he's doing is he's using the 3 parameters that you gave the function at the beginning, and he's doing something with them. So what the parameters allow you to do is to execute a function, but like customize it with different numbers. So in this scenario, the input command will allow the user to enter a number, and then the function to run for the numbers that the user gave.
Yeah.
I don't know if I'm being clear. You can ask questions in the workshop channel.
Yeah,
If
I think that was
there's something
well said.
clear.
If it's still unclear for you guys, please let us know like what's confusing you. But I think the way Fred explained it was very nice, and I got to drink some water, so now my throat is good.
Yeah.
Before we run this, let's get rid of this. Before we actually run this, there's one final thing I want to specify. The input, actually, let's just show you what input does, right? So if you do input, it's going to let you type something, and this is going to be taken as the input, okay? And if we assign this, so let's do value is equal to input. When we do this, it's going to run, it's going to let you input something. So let's say our value, let's say it's bonjour, okay? And now we check value. Now bonjour is stored within value. And one thing you have to keep in mind is that the input is always going to be a string, all right? But when we look at here, we don't want it to be considered as a string, right? We want it to be considered as a float, because you can't put a string to the power of something, right? Like this is going to give you an error, even if it's a number, right? So a string of 5 to the power of 5 or 85, or actually it work. Really?
Oh yeah. Basically.
Oh no, this
yeah,
is
Gong.
times
What
85.
you did is just multiply.
Yeah. I multiplied the string by 85, right? So 5 times 85 is not actually this, right? This is just the string 5 repeated 85 times. So actually, yeah, I'm wrong.
Do you want to show them concatenation?
I don't think it's really necessary, but I'll just show you a quick example how you can multiply strings. So you can do bonjour times 4. You can also add strings. Right, so if you do bonjour plus bonjour, you can actually concatenate them together. But that's not really what we want, right? We want this to be considered as a float. So we need to convert our float, our input, our string, into a float. And then it's going to work. Right, so if we do this, do this, do this. And now we finally finished our function. And if we run this, now it's going to ask our first input. So our first input, let's say A is 4, B is 8.456, and C, we got to make sure it's negative. So minus 4 or minus 5, let's say. And there you go. We have our 2 answers, right? And see, now instead of having to rerun it because it's done, we can just keep writing, right? So now let's try something where it's going to give us an error. So if A is positive, B is positive, and C is positive, there's not going to be an answer. So it just gives us no answer. Instead of crashing, because we did the try except, it's going to catch the error and prevent our prevent the thing from the entire thing from crashing, right? So we finished our first function. We built our quadratic solver. Good job, everyone. But there's more stuff coming because we still have around 15 minutes left. So we're going to build some more exciting things. Hopefully this first part gave you guys a really exciting introduction to what you can do with Python with very few lines of code. So we did this in 22 lines of code, and there's like space in between. So just imagine the cool things that you can do. What we're going to do now is I'll show you some cool things that I did. The cool thing is actually going to come later. Okay. Now what we're going to do is introduce you all to libraries. Libraries are very powerful. Let me go to my presentation. Oops. Which one is it? This one. We're going to go into plotting. Okay. And when I say libraries, what I mean is a collection, basically a Python library is a collection of functions and methods that allow you to perform many actions without writing your code. So these are code that developers much smarter than us students right now, have written to make our lives much easier. So here are just like an overview of many of the libraries that Python includes, such as Senpai, Pandas, Matplotlib, SciPy, sklearn, a bunch of these, and we can just import them and use some of the functions that they've already written, and it makes our life super easy, and we can make some really cool things. And today, we're actually going to use two of them. The first one we're going to use is Matplotlib, and later on we're going to use Senpai for integration and derivation. For Matplotlib, it is used for plotting. So let's take a look at how Matplotlib works. The cool thing with repo.it is that you don't need to actually install these libraries. They're already pre-installed. But if you're going to go and code in your own computer, you're going to have to install them, which is why I didn't want to bother today, because if you're a beginner, you have to look up some stuff and you might run into errors. So I just didn't want to bother and keep things as simple as possible. So we're done with this Python file. Let's create a new file and let's call it plotter.py. So the .py just specifies that this file is a plotter file. If you have like there's like .html or .docx, which is a Microsoft Word document, that specifies the type of document, right? So we want to specify that it's a Python file, so it can get executed in Python. So the first thing we're going to do is import this library, right? So the way we do that is import matplotlib, and we want a specific module within that library. So module is like a smaller part of that that entire library. Okay, so we want to import it matplotlib.pyplot, and we want to import it as plt. What that does is later on to call this, you only need to write plt instead of matplotlib.pyplot. So this would work, but instead of you would have to write matplotlib.pyplot dot something. So if you import it as plt, you can just write plt dot something. All right. So we have our library imported, and let's just do a very simple quadratic equation, right? So a quadratic equation, again, we're defining a function, and our input is going to be, our argument is going to be x. And this time, instead of using print, we're going to do something called return x to the power of 2. And what this can do is basically assign a certain value to a variable. So let's say you wanted value is equal to quadratic function of 5. So value is going to be equal to 25. If this wasn't return and it was print the value, this is just going to print out over here the value of x squared, but it's not able to assign that value to another variable. So when you do return, this it's like it gives you an output, and that output is going to be assigned to value that we define over here.
You want to just print value to show them the.
Sure. Okay. So let me just print value, and let's run this. Oh, I think I have the wrong file. Oops, F11. Is that gonna? Yeah. How does it?
Oh yeah, it runs main.
Yeah, because it's named main, right? Okay.
You can just comment the code out.
Yeah. Okay. So the problem is that with this is where it gets kind of complicated with like paths. Basically, this is like attached to this file, but we want it to execute this file, and I'm not too familiar with repo.it into how to change this so that it runs that file, but I think the reason is that it's called main. Well, I'm not even sure, so I'm not going to pretend like I know. what I'm going to do is get rid of this code, and I'm going to put this code over here. The code is actually on our GitHub repository, so if you want to refer to the entire code, I'll link the GitHub at the end of our workshop today. So let's just run this, and this should return 25. Okay, all right. I'll just show you guys if you do this, it's gonna give you an error. So it's gonna print out 25. Not an error, none. Okay. There's a slight difference between none and error, but it doesn't crash, but it doesn't give you what you want, right? Because the reason for that is, as I said before, it prints out, but when you try to assign some sort of value to the value variable, this doesn't return anything. So it's just going to be none, which is like there's nothing. And that's why it gives none. On the other hand, if you do return, then this is going to work. All right. So now we built our quadratic function, which takes an x and it returns the x to the power of 2. Now we're going to use Matplotlib. And the way we use Matplotlib is extremely simple. All you have to do is write plt.plot, and you have to specify a bunch of arguments, right? So remember, the arguments can be as many as you want. In the case of when the developers built this, there's a few arguments. There's some that are mandatory and some that are optional. Okay, so I want to show you guys, before we actually built the quadratic equation, a simple plot, a line. Okay, so let's say it's the first argument is the x values, and the second argument are the y values. Now you see these two brackets. These are things called lists. Fred, do you want to explain what lists are as I take a sip of water, please?
Okay, yeah. So basically, what a list is, actually, maybe I should just share my screen. Like I have a repo. Okay. Well, okay. Basically, what a list is, it's in square brackets, and you can put anything you want in the list. You can put a string, you can put a float, you can put an integer, and after that, a list contains those numbers. So you can assign a name to that list by giving it a variable, just like you'd assign a value to a letter. For example, if you say A is equal to the list, or yeah, for example, exactly. So you give it a random name, and then what a list is, it's called an iterable. So which means you can go over it. So for example, if I say, you can do what's called a for loop, or yeah, okay. For a for loop, what it does is it goes over every item in that list. You don't have to write item. Item is just the name we give to that, whatever. Wait, what happened?
This is just because it doesn't, like, I don't know, their console doesn't work that way, but we can do it. Let me just rewrite this here.
Yeah,
rewrite it here.
Yeah, that's why it'd be easier if I had the screen. So you want to just like write it.
Okay, let me just write like.
Yeah.
And then let me put a string.
So you have a list of stuff, and then you can go for, and whatever you want. It can be I, it can be A, and then what happens if it goes over every item in that list, and then it does it for every item. So it's like a while loop, but it only does it for the length of that list, and it goes over every item. Yeah. So what you can do with that is, like, the possibilities are infinite. You can do anything. If you have a list with only numbers, you can do like print I plus 1, and then it'll return every number plus 1.
Yeah.
Or yeah. So basically, lists are super useful. They're a really basic component of Python. You're going to be using them a lot.
Yeah.
And yeah, I don't know if there are any questions. Yeah, please do ask them, because I really don't know. Like,
we're gonna see in a second why lists are so useful. Okay, but for now, let's just do this plot, I want to show you guys how the plot looks like first. So plt.plot, and then we're gonna save it, and we're gonna specify a path. So this, let's just call it image.png. So it's gonna, when you run this, it's gonna save a new file called image.png over here, right? So let's run this. Come on, image.png should show up. All right, there we go. And you can see it's a line, right? So the x values are 2 and 4. So 2 and 4. And the y values are 1 and 2. 1 and 2. And that gives us a line, right? That's not what we want though. We want to plot this function, and we're going to start off with a quadratic equation. And it's not going to be a line, right? It's going to be a curve. So what we need to do is store it inside a list. So the way I'm going to do it is I'm going to take a bunch of points and have so many points that it's going to look like a curve, but it's actually like a combination of lines, but it's so tiny that it's going to look like a curve, okay? So let's first create our x values list, or I think something clear would be x list, because an empty list. So we're going to initialize it. It's going to first be empty, and we can later populate it by just doing xlist.append, and we're going to append like a value like 3, like 5, okay? But we're going to do it inside of a for loop. So let me write this first. Start times 100, or actually 0. Let's do 0 100.
Yeah, just want to explain like what the for loop is and what the range.
Yeah, go for it while I type.
Okay, so basically the for loop is, like we showed you, it goes over every item in a list. And what range is it's actually a list of every number in the range that you specify. So for this case, it's from in range 0 to 100. So what it's going to do is it's going to do whatever he says for I equal to 0, then for I equal to 1, then for I equal to 2, until 100. So the append function in this case, what it does is it adds a value at the end of the list. So for example, xlist.append, and then in parentheses, you put what you want to add to that list. So what it's going to do, it's going to go for I in range 0. So it's going to be 0. It's going to add 0 to the x list. And then it's going to do whatever for the y list. And it's going to go back and it's going to say for I is equal to 1. It's going to add 1 to the x list. And so at the end, the x list is going to be 0, 1, 2, 3, 4, 5, etc. So exactly. So here what he shows is just what I is. And this is what we're going to be going over. And then what he's doing for the y list is just running the quadratic function with the parameter of I. So what it's going to do is y list is going to be I squared. So yeah.
Yeah, and the I, as Fred said before, is not mandatory. So you can not even refer to it and do like print hello, and this is just going to run it 100 times, okay? And run. Oh, there we go. Under here. So it's going to print hello 100 times.
I don't know if it brings super clear to everyone, so please don't hesitate to ask questions. Yeah. It really shows us what you're thinking, or just tell us if everything's clear, just so we know that you're still following.
Yeah. And the reason we do this, so we're going to populate our list, right? And we're going to take from 0 to 100, and the x, so imagine the x-axis, imagine like a quadratic equation. The x-axis is going to go from 0 to 100, but actually it goes to 99 because when you specify range, this first value is inclusive, the second value is exclusive. Let me just quickly do demonstrations on for loops. So the minimum amount of arguments for the range is actually 1. So if you do for I in range 4, this is going to print 0, 1, 2, 3, 0, 1, 2, 3. So the 4 is exclusive. And it goes from 0 until this value minus 1, okay? And if you have two arguments, so it's going to be start and stop. So it starts at 4 inclusive, and it stops at 15 exclusive. And you go from 4 to 14. And the third argument is going to be step. Step is, it has to be an integer, right? So let's say you want to step every 3, right? So the I is going to skip every 3, so 4, 7, 10, 13, right? Notice even though it stops at 14, since it steps every 13, it's just going to, every 3, it's just going to stop at 13, okay? So for our case, our step is by default 1, so we don't need to specify it. Later on, like, we want to be able to, like, let's say we want to see it from 0 to 10. It's not going to look nice, okay? So I'll show you guys a nice trick later on. But let's first do this. So let's uncomment everything. Yeah, the comment thing is, basically I do control and the slash, which is next to your period. And what this does is basically makes this gray, and when you run it, it's not going to consider that code. So it's pretty useful if you want to test out some things.
Alright, you want to just explain like what a comment is like in the first place? Just so like with the hashtag and
yeah, so you can
just explain those, yeah.
You add a hashtag in front of it, and the computer is gonna, or the compiler is gonna overlook that code because it.
Yeah.
Another way to specify a comment is having three like quotes, and now you don't have to like put a hashtag in front of each. You can just put 3 quotes from the beginning of the comment to the end of the comment.
Yeah, so just basically like a quick information. The comments are basically for other humans that are going to read your code.
Oh yeah.
It gives the indications as to what the code does or whatever you want to say to another human that will read your code.
Yeah. So yeah, when you comment things, usually even when you do like all the code you want, let's say you want to add some human code, right? So you want to explain what you're doing. What I usually do is for my function, I explain that this takes a parameter and like outputs the parameter squared. It takes the parameter, outputs the squared value. So then like I can explain, like this is obviously very simple, but once it gets more complex, it's very helpful if you want like other people to read your code, for them to understand it better, right? So if you can just quickly explain your thought process in a comment, then it's very helpful. So I'm just gonna leave it here. And finally, we can plot it. So we're gonna plot X list and Y list, right? So right now, once this is done, there's gonna be 100 values inside the X list and 100 values inside the Y list, right? So 0, 1, 2, 3 until 99. So when we plot this, it's gonna plot it, and we gotta first save it, right? So save fig, and we're just gonna still call it image.png. So it's gonna replace this image with a new image. So let's run this. And now, yeah, it's a curve. Now the thing is, let's say you only want it from 0 to 10, right? So 0 to 10, so 11, because 11 is exclusive, so it's going to go from 0 to 10. We're going to see a problem. And if you see here, well, it's okay, but it's not really, we can make it smoother, right? So a trick I had, this is like a little more advanced, is you start from this value and you want to scale it up 100. So you scale up everything 100 and you downscale everything 100 in the I. This is not really necessary, but what this is going to do is just increase like the number of like small lines, you know, between each point. So let's say if it was 0 to 2, let's make it more obvious. 0 to 2. Yeah, it's not really necessary, but I guess I'll show you guys anyways, because it's cool. So if I run this, it's gonna look pretty bad. Okay. See, it looks pretty bad, right? So it's only 2 lines. So if we want to fix this, we can scale it up 100. 0 times 100 is still 100, but if it wasn't 0, you would have to multiply by 100. And over here, we just downscale it by 100. And in the end, it's still going to be the same. So let's run this. And there we go. Alright, nice trick. So the reason is with range, as I said before, the step, you can't put like decimals. You can't step by 0.1, 0.2. It has to be integers, so 1, 2, 3, like an integer value. So to overcome that, I just upscale everything over here, make it a large range, and then just downscale it inside of the for loop. Hopefully that makes sense. Alright, so we plotted, and now I want you guys to try out like different functions. Okay, so instead of a quadratic equation, let's just write a function. It also takes x, but instead I want you guys to write like your own function. Okay, so let's say you want 2 times square root of x, 2 times x to the 0.5, for example. Okay, and instead of here, we don't want to run the quadratic function. We want to run. We want to. No, is this gonna crash on me? We want to run. Okay, it's still here. Okay, we want to return. Okay, 2 times x to the power of 0.5, and we want it to run. Yeah, here. Instead of quadratic function, we just want it to run a function. Okay, and now we can plot out different functions. There you go. So this is the square root. So I'll give you a minute. Just try out your own function, and just using multiplications, additions. So if this I do plus 4, it's gonna be something different. So just try it out, and you're gonna see it's gonna change. So now it shifted by 4, right? So it starts at 4. While you guys are doing that, I'll show you what you can do with an IDE. So what I have over here is my version of the code, and I don't need to save it. I can just plot it. Can I full screen this? Oh, no, I can't full screen this. Okay. So if I run this, so it's the same thing. Here I also did like input, and I did a start and end. So it's slightly different, but it's essentially the same thing. I scaled it up 100 as well, and it's x squared as well. Okay. So if I run this, I have to specify over here my start. So I'm going to start at 0, and let's say I want to end at 10. And what you guys can see is an interactive plot, like a sort of interactive plot. So you can move this around, you can zoom in, and you can go back to your original, right? And you can't really do that with like an image. That's why like you might want to look into coding on your own like your own IDE instead of using repo.it. And over here I also added a style, but you guys don't really need that. I just think that it looks better because over here like there's no grids. So if we just specify over here the style, so we got to import from Matplotlib, import our style, and we got to specify the style that we want to use. So let's say we're going to use it's called ggplot, and if we run this, we have our grids now. Okay, so it's easier for you to see. So far so good. I take that for a yes. Did you guys try out your own functions? Could you guys like show me some of your functions in the chat, in the workshop chat? I want to see what you guys did.
Oh, also, I've just been notified that there's going to be like a participation, like a participant form, like an information form where that you can fill at the end, just so like it's going to be posted on our general chat. So
Okay.
please don't forget to fill that out at the
Louis taking care
please.
of that?
Yeah, he's going to send it in the general chat.
Okay, perfect.
And he just wanted me to tell everyone to,
Okay.
well, to like fill it out.
Okay. That works. Thank you, Louis. So that's our basic plot. I want to show you guys what I did with an ellipse, right? So this is like not something we're gonna code, but a Bladger parable. You didn't really reproduce what was made. I had to deal with something on the side. Here, I'll send it to you, the code right now. 1, 2, 3. I'll send you the code. So Python. 1, 2. Here's the code for what I wrote for this part. I want to show you guys what I did using the same thing, except I made an ellipse. All right. So our function takes not only x, but it takes the a and the b argument. And since if you think of an ellipse, there's 2 y's for 1 x, and it's a bit harder because it's hard to trace like around the ellipse. So what I did was just do a scatter plot. So I just did points, and so here I run it and I specify my a. Let's say if a is 4, b is 5, and we have like this cool ellipse, right? So I can figure out something to connect the dots, but I haven't had time. If you guys want to try it as well, it's on our GitHub repository, which I'll link at the end of today's workshop. But yeah, it's just super cool. Again, you can pan around, look at your points, and we can specify here. I can also like scale it up. Like a simple solution would be just put more points onto this, because right now the points are very spread apart. So if I just reduce the distance between each point by adding more points over here, then we can have a nice ellipse. Yeah. So that's what you can do with Matplotlib, like a simple introduction. So now we got 23 minutes left, and I want to introduce you guys to integration and differentiation. It's super cool, and you barely need any line of code to do that. And by the end of it, you'll be able to like integrate your own functions. And if you have homework, you can double check using the code that you wrote. Right. So again, I'm gonna get rid of this, and let's start with our advanced solver. So let me go back to my presentation. I have like one slide on this. This is the cool plot I showed you with my ellipse. And now we're gonna do differentiation and integration with Senpai. So Senpai is another library, just like Matplotlib, and it's a library used to do like a lot of math things, like integration and differentiation. So let's look at how it works. First, we need to import Senpai, and we want everything from Senpai. So the asterisk just means we want everything from Senpai, all the functions, all the classes, everything. All right. So now whenever we write things like we're gonna write this first line is x equals symbol x, it doesn't give us an error even though we've never defined symbol, because this symbol is gonna belong from the Senpai library. You don't actually see it. If you look at their documentation, and this is basically the same thing as if you were to import Senpai and you write senpai.symbol, right? It's the same thing, but since we imported it like this way, we can just write it this way, right? And the symbol, what it's going to do is recognize this x. So when we're going to do, let's write our function, and let's start with a simple function like 2 times x, and later we're going to pass it, let me just write out everything. It's like 3 lines. Function dot differentiate x. That's literally all you need, okay? So the x, if you don't have this, if you just, my keyboard is wrong. Or, it's fine, I think. Okay, F11. And if we comment out this code, this is gonna give us an error, right? Because x, it's not a string, because you didn't put the quotes around, and it's a variable, but you haven't defined it, so it's gonna give you an error. So if you run this, it's gonna give you an error. But first of all, it's gonna install Senpai, and since it's an online IDE, it's gonna take a long time before the code executes. And once it's gonna do that every time you run. So that's why I recommend, like, once you actually get into more advanced stuff, just get your own IDE on your computer, and you can run it like super easily. Yeah, so it takes a lot of time. Yeah, so it's gonna give you an error because x is not defined. All right, so x, let's do it this way. Uncomment it and do our function, define our function as 2 times x. And once you differentiate this, it's going to return something to you, and we just want to print it out, okay? And once we run that, it should be good. So I'm actually going to pull out my own editor because this is taking way too much time. So I already wrote this code, and let's just do 2x for now. Oops. Our function is equal to 2 times x. All right, so I can just simply run this in my own console. So this is like the same thing as the one on the internet, but except for my own computer. And if I run all of this, and I want to print the differentiation, it's equal to 2, right? Which is the answer, because d of x over dx is 1. And if you integrate this, it's going to be x squared, right? Because the integral of 2x is 2 times x squared over 2, which is x squared. So that's really cool. And to show you that this really works, I wrote this super complex function, which uses the e, and e alone is not like, it's not anything, so I just imported math, and math.e just gives us the e value. All right, so it's another library. This one's actually built into Python. And if you want to use the e value, which is 2.718, you just write math.e. So this is 1 plus math e to the power of x divided by 1 minus e to the power of x, right? And if you differentiate that, you have this. You have, yeah, that's the answer, right? It's different from the original one. I'll zoom in here. So you have your answer, and if you want to integrate this, it gives you like a log of something. It's a log of e to the x minus 1, something like that, okay? So yeah, try it out and try out your own functions. But yeah, it's super cool. It's the same thing. I don't know if you guys use F11 integral calculator. That's like what I used to use for my own like to verify that my answers are right. But let's say sin x cos x, sin x times cos x, like the integral of sin x cos x is sine, what is this? What is this? I don't understand. Okay, let me try something else. Sin, I don't know, 1 over 2 times sin x times x, sin x times, it should be like this, sin x times x to the power of 0. Or yeah, x squared, let's say. All right, let's just do this. And okay, here's your answer. And let's see if this works in our PyCharm, or our Python. So this, remember, to the power 2 asterisks, and sine of x is not sine, like the our Python doesn't know what sine is, so we can just do, or actually Senpai already has defined sine. So as part of the Senpai library, just like how Python, the symbol function is already defined, I think sine is already defined. I'm not sure actually. Let's just try this out. Sine of x. So let's try this. Hopefully it works. Yes, it works. And if we integrate it, I think that's the same answer, right? As x sine of x minus. Is this the same? I mean, it should be the same. Yeah, it should be the same. X squared cos x. Yeah, x squared minus 2 cos x. It's the same, right? Pretty sure it's the same. But yeah, the problem is that it's not as readable, right? So what we're going to do now as our final step is do something. This is more for advanced people because we're going to use a Jupyter Notebook, and we're going to convert this into something that's much easier to read called latex, right? Latex, which is what they actually use to convert it into something that's readable. All right, so let's do that. Before I do that, do you guys have any questions about how these 5 lines of code work? Because it's not that there's not many lines of code, but if there's like one line you don't understand, please let us know. But yeah, see, when you differentiate 2x, it's equal to 2. Fred, do you have anything to add? I mean, if you don't...
I don't think so. Just, like, if you have any questions, we'll be there after the workshop to answer them.
Okay.
Like, more personally. At least I'll be there. I can answer questions. I don't know.
I guess that's pretty much it. Now I want to show you guys the cool stuff. Okay. So we're not going to use repl.it because it doesn't support it. What we need to do, I'll quickly show you how I run it. But if there's anyone here who already programmed, then you can follow along. If not, you can just watch and I'll show you what you can do and get you excited about what you can do with programming because it's so cool. And hopefully I'll inspire you to keep learning after this workshop and try to do what I did right now. Okay, so I'm gonna go where my Python file, my file is. So it's inside workshops, inside one. Don't worry if you don't understand this. And I'm gonna just execute my Jupyter Notebook. Alright, so this is what we call Jupyter Notebook, and this is like interactive Python put to the next level. Okay, and we have this called IPython Notebook, and see how this is automatically converted into something that looks super nice. Yeah, that's the reason why you want to use Jupyter Notebook. Okay, so here it returns a latex form. So let's first rerun everything here, and let's see, because if it doesn't give the same, then something's wrong. So our function, this is our function, and let's try to integrate it. Okay. I think we have to do integrate. What if we do integrate function over x? There we go. Alright, is this, I think this is different from what we got over here. That doesn't make sense. I think we wrote something wrong. Sine of x times x to the power of 2. 1 over 2. I think this is the problem. 1 over 2 times sine of x times x to the power of 2. Yo, Fred, what's the problem? Why is our integrations different?
Did you put the parentheses everywhere?
Yeah.
Like the same places?
Yeah. X sine of x. X sine of x plus cos x. Yeah, I think it's right. Actually, it's right.
Is it the same thing?
Yeah, it's the same thing. I don't know why they messed up, I guess. But over here, I'll just show you guys that it's legit, alright? So over here, the answer is x sine of x minus x squared minus 2 blah blah blah. Over here we have minus 0.5 x squared. So this is, because this you can actually pull out a constant and you put it there. This is actually a more simplified version of what we have over here. So x sine of x is over here, x sine of x, and cos x sine of x plus cos x, because minus, you see here you distributed your minus and it's plus cos x, and then you have your x squared cos x over 2 with a negative sign. So it's the same thing. And here I guess they didn't put the plus c, but see, we get the same answers. It's pretty damn cool, right? So try with your own. If we do our function, the sine of x can give us, sine of, we need to put our parentheses here, and it gives minus cos of x, and we can differentiate it, and it's cos of x. It's really cool. You can check your math equations this way instead of using integral calculator, and you can say that you wrote it, you did it, you verified using your own code. So that's pretty much it for today. Let me go back to my presentation, I guess. And yeah, making it look good. So we made it using latex. I didn't really show you guys how to do it, but essentially the code is the same, except what it returns is a more readable version, just because of the fact that we're using Jupyter Notebook. And so if you get this installed and you run it, the output will be something that looks much nicer. But I'm pretty sure you have to install a few other things, like latex, and if your computer supports it, then it's going to return this. Let me see my presentation. Now before we actually end it, I really want to give you guys some more guides if you want to pursue this project. So we briefly explored what Matplotlib could do, which is, I remind you, a Python library. I actually have this really cool code that I found from Matplotlib. If I run this, look at what we can do with Matplotlib. You can do animations, and this is a pendulum, a double pendulum, and it's much more complicated. You have your dy dx, so you can they do derivations, dt, states, x1, specifying like the positions, animating it, and then showing it. So it's really cool. So I encourage you guys to look into Matplotlib if this is something you're interested in. If not, we also have Senpai for more math stuff. And the documentation is, if Fred, you want to link the documentation, well, you can find it pretty easily. You just do, like, if you write Senpai.
Yeah, you just write Senpai and you'll find it.
Yeah, and you'll find it. And I really recommend this because you should go to the original source of information. This is how I put together today's tutorial, most of it. And I was just looking at some of the documentation, some of the cool things you can do. Same thing for Matplotlib. And you have examples, tutorials, documentations. Alright, so you can do a lot of customizations. You can do sample plots, images. Like it's very cool. Okay. And as for more resources, where's my presentation? Okay, more resources. We have, as I said, we put some more resources for you at curious.ca/resources. Oops, I think it's called student-resources. Student-resources. Yeah. And basically we talked to you about, what we wrote was basically explaining to you how there's like 4 main applications that you can go into: web, app, computer science, and data science. And we have like a bunch of courses that we recommend for students, and a lot of them are free that you can consult. So if you want to like get started like learning more about coding, you should go here. The goal of today was really to spark your interest, and because we understand that through a workshop you're not going to learn everything. My goal today was mostly like introduce you to some things and get you excited about it, and these courses are really going to build more of your foundation, right? Like a workshop is not going to fully build your foundation. It's going to get you started, get you interested in different concepts. But it's really by following these courses that you're going to really build a solid foundation. And that's going to allow you to build more exciting projects. And, if you have like other recommendations, we're going to keep maintaining our Discord server. So if you have some ideas or if you run into any problems, just write it down. We have our channels for that. Write that down, and then we're going to try, students are going to try and help you. Mentors are going to be there for you. If you're not sure what you want to learn, we're here for you. And next week, we're going to continue the series of workshops. And next week, we're actually going to talk about servers and APIs. So it's going to be more on the web development side, and it's not going to be Python. So if you're more of a web or server guy, then definitely come to that workshop. It's not going to be hosted by me. It's going to be hosted by Nicholas, who's a university student. And yeah, I'm really excited because even myself, I'm not that of an expert in in the server side, the client side of web development. So it's definitely something I want to learn about and get myself interested. That's pretty much it. Do you guys have any final questions? And thank you for your attention today.